Hello, my friends. Today I'm going to go through a lesson on using DynamoDB. This is a written lesson that I have for my students, and I'm going to follow along with it just in case there's anything that while they're reading doesn't make sense. So basically, anybody can watch this video and learn a little bit about DynamoDB, and I'm going to include underneath this video, if you're watching this on YouTube, a link to the written tutorial. So with that, let's go ahead and get started. So I'm going to share my left screen here. So this is the tutorial, and it's to get you started on using a NoSQL database that's highly scalable and maintained by the provider. So that's why we call it serverless. So you don't have to provision it yourself and back it up and do all the security on it. Like serverless means that they're going to take care of that for you, which is amazing because you could scale this up to, a worldwide shopping cart application as an example if you were Amazon or something like that. So this is a very robust service that you could use. And in some ways, it's going to be faster and more scalable than a typical relational database, which might make a lot of sense for your use cases. All right, so with that in mind, let's talk about what the problem is. And so the situation related to this lesson is that for a donut company, there are sensors that are at the different restaurants related to whether the lights are off and on, what's the oil temperature, what's the heating and air conditioning, what are the measurements of that in all of the stores. So, and if you measure those things as frequently as once per second or once per minute, whatever your measurement interval is, there could be millions of readings a day if you had 33,000 physical locations across the world. And so the idea is that as this particular entity, Paradise Donut Company, wants to think about where should I store this type of information that's being generated so quickly and in such volume. Let's go ahead and put it into a NoSQL database, in which in this case will be DynamoDB. Uh, oh yeah, and so let me just make some other notes here. Um, Also, in addition, well, we're also going to be able to store things like, it's anything related to a particular building. So we're going to need to restore facts about like what buildings we have, as well as every single thing that we're measuring in that building. All right. So the first thing we're going to do is assume that there are over 100,000 sensors across the locations, and we're going to create essentially a table that has a unique ID called sensor ID. It's going to have a status determining whether whatever it is that we're looking at is on or off, a sensor type. So is it a refrigerator, a room, a fryer? And it's going to have a store ID indicating what store that it's in. So one of the things that's different about NoSQL databases is you actually need a lot of practice thinking about things differently. If you've been trained traditionally to think about relational databases, then what's going to happen is you're used to doing normalization of tables, and you're not going to be doing joins with NoSQL databases and tables. And so you actually think about things differently. And so this is an example of a use case where rather than having 5 different tables for 5 different types of things that you're tracking, you're going to have one table that stores a whole bunch of different things, refrigerators, fryers, as well as the buildings themselves. So it's a little hard to wrap your brain around, but it makes it so that if you design things correctly, that retrieval is amazingly fast, and the tables are basically infinitely scalable. So this looks like a typical relational database table, and this is a simplistic example to begin with, but it's going to get harder later on, so don't be fooled. So initially, I gave you a description that we're going to have unique ID, whether it's on or off, what kind of sensor it is, and which store it's in. All right, so I'm going to move this over to the other screen, and because that way I can read it at the same time as I'm doing things in the other one. So first thing I want to do is go over to DynamoDB, and I want to find something on the screen that says create table, and then I want to name my table sensor readings. And actually, just real quick, let me click back. I just want to make sure that I haven't already created one that I have forgotten to delete at this point. And what do you know? I have. So just to make this easier for me, let me delete that. I had a sense that that could be the case. So I will click Create Table again. You might imagine that I've done this once or twice. And so that way I get things left over. Okay, and then I need essentially a primary key, and we call this the partition key. And oops, I messed that all up. My table is called sensor readings. So sorry, go back and update that. And my primary key, if you will, my partition key is called sensor ID, and I'm going to make it type number. And then look at this. For the types of values that we're saving, usually in a relational database, you have like 6, 7 different flavors of a number, several different varieties of text. And for this, when you're working with this thing, it's just basically, is it a number? Is it a string? Or is it binary 1, 0? So that's another weird thing to wrap your head around. Can you do pretty much everything you can in those other databases with these 3 types of values, even dates? Yeah, technically. So we'll worry about the rest later. Okay, we're going to go down. We'll accept the defaults here and click Create Table. And we see here in the list that it is being created. It will take a moment. Status is not active yet. So rather than pausing the video, I will just try to sit here awkwardly for a moment. Okay, they tend to get created pretty quickly. All right, so let's go ahead and add data. Now, think about this. We did not create a schema. So NoSQL tables are typically schemaless, which makes you scratch your head like, well, how does this all work then? Well, the way it all works is that it's tied back to that primary key, partition key thing. So that is unique, and everything else that's would be in what you would call a column or a field is all just, it can be different for every entry. All right, so let's just see how this all works. We're going to click on sensor readings, and we have this selected, and let's go ahead, and it says that there are 0 items in there. So items is their word for record, and we're going to go and click actions and create an item, basically insert a row. And so the first one that we're going to enter in here, we'll call it sensor ID 30,000. And all right, so that's the record identifier. Let's go ahead and add some columns, which we call attributes in this domain. So we go over here to add new attribute, and we're going to add a number, and we're going to do status, and we'll do 1 for on. Let's make 2 more attributes. We'll have one of them be string, and we'll make another one be number. And so the string will be sensor type, and we'll call this a friar. And this one will be store ID, and we'll say it's store number 15. So we're going to create a record. It's got I guess, a unique identifier for the sensor that's being measured. It's related to a cooking fryer. And we're not really getting a temperature right now. We're just saying whether that's on or off, and it just happens to be in store number 15. We click create item, and we get a little message about read capacity units consumed. So you get charged based on the read and the write units that you are using up. So there are different things that you can do to affect that. But in low quantities, it's not really going to matter. All right, so you can see our record right there. Now let's go ahead and create some other records. So I have a list here of records that I'm going to put in. So um, a refrigerator, an air conditioner, a bathroom light, a store light, a fryer, um, on and on. And so just conceptually, what I'm imagining here is let's just say that I have 100,000 sensors. I'm just looking at this moment. If I were to go into my table after the fact, I'm just trying to see if the last time I checked, it's either on or off. So it's not like a history over time with the date. It's just for every single sensor, is that thing, that electrical item turned on or off? And I have a record of all of that across the world now. All right, so let's go ahead and get a little practice with that. Go back and pause, take a screenshot or whatever if it helps you, or just pull up the document. So as some practice, let's go ahead and create some more items. So I'm going to click on create item, and this one's going to be 30,001. And you can't do querying and stuff like that unless you enter all of this in. So anyway, add a number, add a number, add a string. So this part is kind of annoying for me. So we're going to go with status, because I have to do this so many times. Status is going to be turned off. What kind of thing is it? It's a refrigerator, and we're going to say sensor type. And over here, I have store ID and 15. All right, so I've matched the first record. Good to go. Let's do this again. Create item. This is going to take a while. 30,002. Number. String. We're going to go with status is 1. Sensor type. Actually, this one's going to be air conditioner type. Oh, yeah, that's a string. Sorry about that. So copy, paste, or cut, paste. Also for a number, we need store ID. This is also in store number 15, create item. All right, 3 more if you can endure that. So we're gonna go 30,003. And I'll just do number, string number. It doesn't really matter what order we do them in. And I'm gonna have status 0. I'm gonna have sensor type, bathroom lights, and then we'll do store ID 15, create item. Let's do this again 2 more times. Bear with me. 30,004. So this is not the kind of thing that you should be just watching a video and trying to soak it up. You should be physically doing this. That's the purpose of this. Number, string, number. So we go with status, it's off. We go with sensor type, store lights, and then we go with store ID 15, create item, and now we'll actually do a different store. So these were all in the same store. We'll do another 30,005 number, string, number. So this is the non-teaching part, so it's kind of boring, at least for me. So thank you for sticking it out. String, fryer, store ID. And so this one will be a completely different store. All right, so look at what we have. We have a bunch of sensors that we just want to know whether they're on or off. We want to know what that sensor is tied to with, and also what store that it is in. Um, all right, let's go ahead and update an item. Now, obviously, we can use this console to create items and also to update items. Longer term, you prefer to use programming languages through SDKs to manipulate the information that's in a table. But just so you know, you can add records through this interface. So let's go ahead and update this one. So we come over here to this particular sensor, and we come in and we say the refrigerator was off, and now it is turned on, and we can go ahead and save and close. Similarly, we can find 30,003, and we've got our bathroom lights, and somebody's going to leave it on. So we're going to turn that one on. All right. Let's go ahead and imagine that maybe this fryer has broken, and we want to, after the fact, denote that it is broken. So we come in here and we're just going to arbitrarily add a number. It doesn't matter if I do string or number for this example. In my notes, I have it as a string, but let's say that it's going to stay off, and we will just add in a new attribute, a new field, and let's just say it's error code 602. Pretend that's something meaningful. So we hit save and close. And so look at this. Look at how it's capturing it. Even though one of these records has a different number of columns, everything just works out fine. There's nothing special to do. Um, anyway, this is really the only structure we have for our table. The rest of it, it's just a coincidence that we happen to use the same attribute over and over and over again, which makes it feel like a relational table, but we can just arbitrarily add in things if we want to, if they're useful. Okay, now let's interact with the data via JSON. So let's go ahead and just click on the first one, 30,000. Notice that we were updating it through a form. If you click over here on JSON view, you can see it in the JavaScript object notation format. So I guess that's synonymous with saying lots of curly braces. And so notice that this is how it looks. So I could arbitrarily just add a comma and another property and another well, I guess this is an object then. I could arbitrarily add some type of attribute that is represented as an object with a name value pair. So what does this mean? Oh, so this is saying, hey, store ID is a number and this is its value. This one is sensor type is an attribute, and this is its type, and this is the value for it. Let me wave my hand. The light just went off in my office, and it's not even coming back on, so I look silly here. Oh well, I guess I'll just sit in quasi-darkness. Okay, so let's go ahead and change the status from on to off. And let's go ahead also and add a model number to this. So after store ID, I will do comma, model number. And so we'll just follow the format that we see there already. And I'll say that this is a string. And we'll say XTF 9,000. And with that, we should be able to go down to the bottom and hit save and close. And I didn't have any syntax errors. And so it correctly updated this record and added what is effectively another column. But we have other things that stayed consistent. So now you're getting a feel for how that works. Okay, now let's look at querying. And I'm going to shrink this up a little bit. All right. So right now up at the top, this is where our querying is happening, but it's hidden. So if I expand this out, we've got query or scan. Um, if I click it to scan and I say run, what this does is it's effectively a full table scan, and this is different than a query. Okay, so let's just kind of talk about the two different ways to do this. Right now, it's not very important. We have 6 items, but what happens when you have hundreds of millions? Imagine that you wanted to query for a single record in here. Well, if you use scan either programmatically through an SDK, or if you use scan using just this interface, regardless of how you do it, notice how it's using read capacity units. It's gonna, if you have millions of records in here, if you use scan, it's gonna go through every single one of them, and then you're supposed to subsequently filter based on some attribute. And so relatively, this is an expensive operation and you get charged more for that. So you're probably gonna see a lot more read capacity units come up if you do things that way and you have a lot of records. The preferred way to always do it is to use query. Um, all right, but first let's go ahead with scan, and we'll just say, hey, we we scanned the entire table, we retrieved back the whole table on the back end, and now we want to essentially filter the results. So this isn't very efficient, but let's go ahead and do it. So I want to look for anything that has a status equal to 0, and I run that, and why did it come back with that? What have I done wrong? Um, should not be the case. What did I do? Run. 6 items. Status. All right, let me try this one more time. Filter. Attribute name. Status. Oh, type number. I think I forgot to do that. So give me status where it's a number and it is on, and I run it and I get 3 items returned. If I did 0 and I ran it, I get a different 3 items that are returned. So this is a way to use it. Notice the number of read capacity units that were selected. Um, let's go ahead and change one of the ones that are off and turn it to on. So I'll do that, and I'll do status on, save and close, and I'll come back here and I will run the query again. Well, technically the scan with the filter, and now it has 2 items. So it's correctly filtering based on updates that I'm making to the backend table. Now let's switch to query. And when we do a query, we're going to be filtering based on, for starters, based on the partition key. And this can be very, very, very important for efficiency. So the first thing we're going to do is just look for sensor ID 30,001. So notice it's not part of the filter. Actually, let me get rid of that. So this is actually part of the top half of our options. If I go here, I don't have that additional option, just says whole table. But if I do this, then it's going to first only grab the subset of the table that begins with this partition key, which there's only one of them. And then it's going to filter it. And this operation is much more efficient. So if I do this one and I click run, it returns back the one record. But notice the read capacity units are just 0.5. So even with 6 records, scanning all of them takes 2 read capacity units, but things are very, very efficient, which is going to save you money if you are filtering based on your partition key. All right, let's go ahead and, well, I'll just note that you can pick any of your attributes, any of your columns, select the right type, and you can do things like equal to, less than, exists, contains. So there's a modest set of filtering conditions that you can use. Let's go ahead now and create a more complicated table. So we could probably delete this. We don't need it I can't remember if we need it anymore for I have another tutorial where I have you interact with this stuff using programming code. So maybe if you're going to be doing multiple tutorials with me, maybe save this just in case we need this for the next one. All right, so I'm going to go back to DynamoDB and I'm going to click, well, I was going to do create table, but I have already created this one. So let me go ahead and delete it and I'll say confirm. And goodbye, and I will click Create Table. All right, let's talk through what's about to happen here. So what we just did was hopefully familiar if you're an experienced programmer, where you had something that looked like relational database table. This one is also in that vein. So let's kind of read through the description here. This is what we're going to create, sensor readings 2. It's got, so rather than on or off, the difference is now we have a measurement that we're taking, like the temperature, and we have a timestamp. So if we have a single item like a fryer, what we're saying is over time, we're going to, and let's just say it's fryer 30,000, we're going to repeatedly capture a record once a second, once a minute, whatever it is that we do for our company that makes sense. And so then we will have okay, so we have 30,000, the timestamp, and then some similar things that we saw before. Sensor type, it's a fryer, store ID 15, measurement, how hot it was in Celsius or Fahrenheit or whatever. So again, this still feels very common compared to a relational database table. The hard stuff will come up later. All right, so we've got a little description of how that works. Let's go ahead and plug that stuff in. So we come over here and we type in sensor readings 2, and the partition key will be sensor ID, and that will be a number. And then the thing that we're adding now is a sort key, and the sort key is timestamp. All right, so if you just have a partition key, sorry, this is going to be embarrassing. I can't remember. I can't remember if you're allowed to repeat the partition key over and over and over again. But if you have a partition key and a sort key, it's a composite key. And while this number will be the same over and over and over again, and you can search based on it, the overall composite key for a record is unique each time. All right, I don't think, let's see, I have a note here to explore some of the other settings. There are, let's see, table class, standard, anyway, on demand. There's a lot of other information that if you're, when you're using it a bunch, it'll matter, but let's, oh, so I have a little note here. So let's go ahead and just kind of read through these and talk about read-write capacity. Let me just switch over to custom settings for a moment. So, somewhere in here we can change the capacity. Where can I set that? We've got a capacity calculator. Interesting. Oh, provisioned. How much capacity are we going to need for reading and writing? So you kind of have two different ways that you can set this up. You can set it up for on demand, like, hey, you guys just figure it out, or if you know the traffic you're going to be getting, you can do it with a fixed or provisioned capacity. A couple thoughts here, just generally speaking, I'm not sure if this is going to apply in this case, but generally speaking with AWS, if you provision what you need, it can oftentimes be cheaper if you're using everything that you plan to use. I don't know if that's going to be the case here. It used to be the case that on demand or the other option was more expensive. The default option was more expensive right out of the gate than if you drop this down from whatever it was defaulting to. But these days, just in the last few months, I've noticed that on demand is actually cheaper because it used to give you more read and write capacities than you need, like when you're experimenting and doing a lab. So anyway, I'll just say on demand is fine. Let's kind of look over what some of the notes are. Okay, tables set up for demand. That's what I just mentioned. It used to be the default was 5 read capacity units and 5 writes, and it was overkill, but on demand is great now. Let's just kind of think about some things related to this. Imagine that there's 3 million total sensor readings that come in each day. That means that there are on average 86,400 readings per second, which means that on average there's 35 writes per second. So you need to plan for that amount of capacity. And so the default setting previously of 5 writes per second would be insufficient for what we're planning to get. Um, Got some other notes here about secondary indexes. So with you can create indexes on any, let's kind of scroll up a little bit here and I'll just describe this. Um, as you have lots of attributes, you can create, if you want to be able to filter or how I should say query efficiently based on this stuff, you can do that. You can do optimized searches on your tables by declaring that one of these attributes, not part of the composite key, but one of these attributes is going to be a key for searching. And then what it does behind the scenes is it duplicates the entire table if you do that. So think about it. If you're generating however many I said here, you're generating well anyway, a 3 million sensor readings a day and multiply that by 30 days in a month, your storage is going up pretty quickly. And then if you select secondary index, then it literally makes an entire copy of your table and you're paying for two tables rather than one. So it's kind of a redundancy is okay in this world. It's not terribly expensive, but it's very unsettling for those from relational database worlds where you just have one source of one copy of things and you're trying to save money storage space wise, but um, not, but in order to get queries that you want in this context, you actually have to copy the whole table, which is weird. Um, all right, so let's carry on. So that was just a little side note. So basically, other than adding in these two different parts of the key and giving it a name, we're going to just leave everything at default settings again. So we go ahead and click Create Table, and now we want to start adding some records here. So we're going to select sensor readings. Wait, well, we thought we were. How about we wait for it to be created first? It's always possible that it might bark at us if we don't, if we try to do something before it's done. Okay, sensor readings too, we're happy. Okay, let's go ahead and, well, we should explore table items. Okay, we need to, I don't know why there wasn't a button there to add records, but so from this interface, all right, let me just go back and do this a couple times. So let me just flip between a couple of these. So if we're looking at this and we want to add items, just create an item. Great. Okay, so we're going to do sensor ID and timestamp. And let's go ahead and just set this up as 30,000. And for timestamp, I'm going to use this big fat number here. Now, in relational databases, typically we have a number, or so we have a like a date or a date time format or a time format that we select. Now, technically, computers just store everything as numbers at the end of the day. So even when you select that stuff, it just goes back to a number as far as the computer's concerned. And one of the things that we can do related to timestamps to work around the fact that we only have three data types in this particular type of table is we can convert any date into a milliseconds passed or seconds passed since the epoch. So when's the epoch? So in people that work with computers know computer time know that there's something called Unix epoch time. So starting in like 1970, they've been counting up like 1 second at a time. And so you can so what you can do is go to one of these websites. Let's go ahead and I'll show you epic101.com as an example. There's multiple out there. And you can say, what is the time in seconds that have passed since January 1st, 1970? And this is that number. So you can use this number and these types of numbers in here. So kind of tricky. Okay, let's go ahead and add in some other attributes. So we're going to have a string, and we're going to have number, and we're going to have another number. And so let me just go ahead and type in stuff from our design. Sensor type, prior, store ID, 15. Measurement, 180. So at this particular timestamp, moment in time, this fryer in store 15 is measuring at 180 degrees. And we'll go ahead and click create item. And I want to enter in these things as well. And so I've got, and these are all for sensor ID 30,000. So just different times. And well, let me do the first one here to show you how I would do that. So I go down, I click create item, and I say 30,000. The timestamp, let's go over here and copy. And I'll paste that in. And we'll add a number, a string, and a number. All right, so attribute name. Doesn't matter what order you put these in either. Measurement 179. Sensor type. Fire. Store ID 15. Okay, and so rather than making you watch this, just go ahead and pause the video, type all of these in. I'm going to do the same thing, and then I'll be right back. But hold on a second. What I want to do, pause, is the recording. I just paused screen sharing. Okay, if you've entered in everything in the top half of things, then you'll have what I have. Here are some optional ones to fill in, and I'm not going to do the optional ones right now. All right, so let us carry on with the example. So your records, I'm going to collapse that. Should be displaying like that. Oops, looks like I have a little problem there. 300,000. Okay. Ooh, recreate item. Interesting. Okay. So just noting that I have a little quiz. I have little questions embedded here. It's like how much read capacity is the full table scan using? It is using 2. All right, now let's go ahead and we'll do this a couple times. So we can do a full table scan. Let's go ahead and just do it like there on purpose, and it uses 2. Now let's go ahead and go to query. Now notice that when we're on scan, it's not asking us to use our composite key. When we go to query, it says enter in basically your sensor ID, your partition key, and what they call the sort key. So the sort key is usually something that you select because you're going to be searching on that field a lot. So I'm going to enter in 30,000 as my partition key. And if you remember, there are lots of results there that are from sensor ID 30,000. And let's go ahead. Oh, and then let's do this between thing. So I'll say between. Ooh, I need to come up with some numbers. I wonder if I can copy this. There should be a range here. So I'll copy that one. Ooh, it needs to be like count up though. So I got to be careful about this. Where is it getting bigger? I'll just take any. Well, no, I still need to look carefully, make sure which is the low end. I'm gonna hope that this is the low end one. You'll have the same issue here. So pick a low one and pick a high one and make sure you got low to high. And oh, that's actually a low number. So let's, oh, it's because it's got the sixes there. Okay, so let's do this differently. Low to one of the higher numbers, just one of them in the range. And notice that we're using the numeric attribute of the timestamp. And so we're able to select something that's between two numbers, and we run, and we get a subset of results returned, and note that it only used 0.5 read capacity units. So this is more efficient than doing the whole scan, which we might have done. Okay, let's go ahead and just for practice, let's go ahead and remove something. So I will just arbitrarily pick something from the list. I will say actions, and I will say delete item. Do you want to delete it? Sure. Okay, so now you've had practice creating, reading, and updating, and deleting. All right, so next, I've got a little note in here about usage costs. And I haven't read this in several months, so I will try and interpret on the fly. It's scalable, of course, but how much does it cost to use this? Well, there are calculators. You can just, for all of the AWS services, or most of them, you can just type in like AWS pricing calculator into Google, and it will come up with the calculator for DynamoDB. And what I said is just as practice, that it's think about how big your records are that you're storing. So you know, if you're going to build a project, you don't want to just go in cold and surprise your company with, oh, this is costing us $200,000 a year. Like before you start the project, you kind of want to know what this is going to cost you, since this is like a utility and you're paying for the service. The record sizes that we've created so far are on average 0.017 kilobytes. And if we're assuming 3 million writes a day, that means we're going to store that much information per day, and we're going to store that much information per month. So you can use those type of calculations in calculators like this that are on their website. So you can enter in information into the fields and run calculations, and you'll see how much it's going to cost you. Again, don't want to surprise people or put your company out of business. And so I do a little example here, and based on the numbers that I was plugging in going through this, it would cost like $10 a month. And you can pay on demand, or you can pay up front. If you pay up front with AWS, things get cheaper. So anyway, as I was updating things with different estimates, I was getting some prices that could be $268 for 12 months of usage, which if this is using the actual numbers of lots of gigabytes that I was talking about, let's see what we have here. Lots of writes. What about storage? Data storage size, 2 gigabytes. So I'm saying we're only going to have 2 gigabytes of storage. So if you only had 2 gigabytes of storage and a fair amount of writing, then it's not too expensive. But if you enter in something a lot bigger, like the 372 gigabytes that you might expect, I can't remember if that's by month or over the course of the year, the number is going to be much higher. So as an activity, I encourage you to go and play with that. Okay, rubbing my hands together. All right, so this is where it gets crazy. Now we've been using DynamoDB, a NoSQL database, as if it were a regular relational database table right now. But and you could, and I warn people, you could make a short career, meaning it's going to take you a little while to come up to speed on this. You could make a career out of design for tables that are highly scalable for certain purposes. So in a typical world, you usually, like, let's just talk about like a customer database, for example. You might have, in a typical relational database world, you'll have a table of customers. And let's just say you're a billion-dollar company. Maybe you have 1 million customers, and you have maybe orders, and you have millions of orders associated with them. And those are two different tables. Okay, mind-bendingly, you're oftentimes looking for ways to, not always, but oftentimes looking for ways to put both types of records into one table that is queryable. So you want to have customers as records in your table, as well as orders of customers in the exact same table on different rows. And that requires real interesting design. And so in here, I have, I say, um, if so, kind of going from what we were doing. Actually, we need a little bit of concept of what we're going to be building. So we're going to have so related to our sensors, we might want to track buildings. We want to keep track of different things in those buildings, like we'll just recognize what is a store or a building, what type of building it is, who's in there, such as managers, and then what type of equipment might be on site, like forklifts, etc. So, inventory items, managers, locations, addresses of buildings, all these different things. So, and actually, let me just pause this for a second and collect my thoughts about all the tables that I have here, and then I'll come right back. Okay, we're going to try to use one single NoSQL table to store 5 different types of records. So imagine that we wanted to store information related to the location of the building. We might call our table building, and we want to have in there a primary key, a sort key, an address, and maybe the day that it was open. We also, we're going to have the same table name, building, but we want to store records of managers. So we might have a primary key, a sort key, their name, and their salary. We also might want to have in there a cash register. So we'll track that as an item that we have. And so we have 2 items there, and then we have a manufacturer and a purchase date. And then over here we have well, that's a retail location. So for like a storefront for a donut store, and this one's like a warehouse. And in our warehouse, okay, similar things, and maybe we're storing square feet because that's important to us. And then maybe we want to have a record of forklifts, and it's got similar fields for the first 2, but again, a couple different things there, like what brand of forklift and when it was created, or when it was purchased. Okay, but how do we use this idea and always call it building? And so here's the trick. The building ID is probably always going to be the same, but we will manipulate the sort key to identify which type of record that we're working with. So let's go up and look at examples. And this is like super mind-bending. So if we're talking about a building, and the building number is, we'll call it store number 1234, and then this is just redundant. We change this when we're going to things that are in the store. So we'll just call it duplicate it when we're talking about a store itself, and that's how we would make, and then here's the address and opened information as a timestamp. Now and then if we're doing a warehouse, instead of S pound, so the first letter is the type of thing that it is. So if we're going to a warehouse, we can go W pound and then put that in there. So these 2 records are just related to buildings themselves. And then the building identifier. This one is just the type of building that it is. Now let's go down to a manager record. Well, a manager is going to be in a particular store. So you use that to indicate the store number. And the S determines what type of building it is. But then for the sort key, rather than duplicating what's there, the sort key we're now using to designate what thing at the store that we're talking about. And in this case, we're talking about manager number 1. And if we have a cash register in a store, we say this store, and then we say register number 1. And so then we could have lots of registers in there. And all of this weird naming relates to how we can do queries on a ridiculously massive table. Here's our forklift. We can say it's in warehouse this number and it's forklift number 1, and we could have lots of them in there. So that's how that works. So we're going to create a table called building, and let's get moving on that. So I'm going to I'm going to go over to DynamoDB because I actually want a list of my tables. I'm going to click on building. I'm going to click delete because I already have that. And look at that, I have a meeting coming up. So I'm going to have to do this in 2 different videos, but I'll get as far as I can. So create table, and we're going to call this building. And we're going to have a primary key or partition key that we call PK and a sort key that we call SK. And we can leave all the settings as they are, and we will click create. And it'll take it a moment. And building is ready to go. Let's go ahead and we want to create some items in there. So one way that I could do that is I could go explore, sorry, I could go explore and then do the create button, or I could do actions, create item. Either one is fine. Okay, so let's go ahead and create our first retail store records. S pound 1, 2, 3, 4, and sort key S pound 1, 2, 3, 4. And then I'm going to add in a string and call it address. And ooh, I need a lot of text there, so I'm going to copy and paste. In we go. And I'm going to need a timestamp, and we'll call this opened. And I have no idea what this timestamp in real world date means, but I'm going to go ahead and click create. Okay, now let's go ahead. So I've got a store one there. Let's go ahead and create one that is for a warehouse. So I will do W pound 3, 4, 5, 6, and I will do W pound 3, 4, 5, 6 again. And I've got a bunch of copying and pasting here to do. I need, for my warehouse location, I need an address, I need an open date, and I need square feet. So first I will copy. Well, I'll just copy my values first, and then I'll indicate what they are. There's my open date, and there's my square feet. So I type in address, oops, open date, square feet. And with that, I can click create. All right, now let's go ahead and create a manager within a retail store or typical donut shop. So create item, and in store number 1, 2, 3, 4, there is a manager with a unique identifier of 1, and then we're going to add in a string and a number, and this is going to be their name. We'll say Dave Thomas, and we will say full name, and we will type in salary, and we'll put in 65,000, right? And we need a couple more of them, and they're going to be working at that same store, so different employees. Let's do, again, S pound 1, 2, 3, 4, and then we'll do manager number 2, and then we'll do a string and a number, and we'll do Dave Thomas's daughter, Wendy Thomas. This is talking about the Wendy's store, if you're familiar with them. And the salary is 66,123. Just having a little fun with that. Now let's go, now let's do a McDonald's manager. So we'll do S pound 1, 2, 3, 4, and we'll do manager number 3, or it could have just been employee number 3 if they're not a manager. We're going to need a string and a number, and the string is going to be full name, and so we'll do Ray Kroc of McDonald's, and we'll do salary, and that's going to be 70,123, and we'll click create item. All right, so look at what we're doing there. We've identified a store, and then in the sort key, we're saying what type of thing at that store. And by duplicating it, we're saying this is store-specific information. And so this is like non-normalized, and so it's weird if you're experienced. And then in the store, you could say, here's one manager, here's another manager, here's another manager. Okay, let's go ahead and add in some cash registers. So I'll say cash register. So in store number 1, 2, 3, 4, we're gonna have register number 1, and maybe it's an iPad or something like that. So we'll do a string and a number, and we will say manufacturer Apple, and we'll say purchased 2202-61101, and there we go. Ooh, and want to know something that's like super nice is you can select an item. So this is already getting kind of annoying what we're doing. You can select an item and you can do actions, duplicate item, and then you have a starting point. So now I can go to, and we'll just have it purchased the same day. Oh, thank heaven, we could just do that just now. Great. All right, and then we'll do it again. Actions, duplicate, register number 3, and we'll just pretend like we purchased it at some much later date as we grew. All right, and I think we're coming up to the end here. And so let's go ahead and create some forklifts now. So we'll do in the warehouse, number 3, 4, 5, 6, forklift number 1, we're going to have a string, a purchase date, and a last service date. So we'll say brand Toyota, purchase date 20119. Actually, it looks like I did a reverse date there. 2019-06-09. So you can do that as well instead of a epic timestamp. Last service date 2022, October 15th. Done. All right, let's grab this forklift and we will duplicate that. And this one is going to be forklift number 2. And we will do ion, and we will do 710 and 2022-21-015, and we will click create item. Okay, so we have in one single table called building a whole bunch of different conceptual types of items that we are differentiating with the prefix F, R, M, W, and S. Those are things that are meaningful to us. And I am going to stop for now because I have to run off to a meeting. And so I will do a part 2 of this, and I will talk about querying this table next.